Okay, so let's look at some examples with indices and surds. We have a problem here, x to the 1/2 plus 3y to the 1/2 quantity squared. So this is a FOIL problem. It's the same thing as x to the 1/2 plus 3y to the 1/2 times x to the 1/2 plus 3y to the 1/2. So if you need to look at it in this way, that's fine. Now, to FOIL, you multiply x to the 1/2 times x to the 1/2. The outside is going to be x to the 1/2 times 3y to the 1/2. Your inside is plus 3y to the 1/2 times x to the 1/2. And then finally we have plus 3y to the 1/2 times 3y to the 1/2. Okay, so now we need to simplify. And we're going to do this step by step as far as we can go. So right here, so when we multiply things with the same base, we add their exponents. So x to the 1/2 times x to the 1/2 makes x to the first power. Now over here, the x to the 1/2 and the y to the 1/2, we could put those together. Now, they don't have the same base, but they have the same exponent. So that's the same thing as xy to the 1/2. And then we move the 3 out. So this would be 3 times xy to the 1/2. Now, second term is exactly the same. So we're going to have plus 3 times xy to the 1/2. And then finally at the end, we have like bases 3 and 3. When we multiply those together, right, 3 to the first times 3 to the first makes 3 squared, which is 9. And then we have y to the 1/2 times y to the 1/2. Just like earlier, this ends up being y to the first. And so when we simplify from here, we have two like terms here. We have 3x to the 1/2, or xy to the 1/2. So we're going to have x plus, each of these makes 6 xy to the 1/2 plus 9y. And so this is actually the same thing. Remember, power to the 1/2, that's the same thing as the square root. So you could also rewrite it this way, and this is a completely correct answer. If you wanted to leave it in this form, though, that should be appropriate as well. Okay, so now we have this problem. So we have 3 times 2x plus 4 times 5 to the x minus 2 equals 27x times 5 to the 2x. 27 to the x, sorry. And that equals, and then we are trying to figure out what's 15 to the x going to equal. Okay, so we've got to create that somehow. So what we do is break this up as much as we can. So right here, 3 to the 2x plus 4, you can think of this as the same thing as 3 to the 2x times 3 to the 4th. Because when we multiply like bases, remember we add the exponents. Likewise here, we've got 5 to the x minus 2, so we're going to have 5 to the x times 5 to the negative 2. That equals 27 to the x. Well, this side is all in terms of 3's and 5's. So I need to figure out, how do I turn this into either a base of 3 or a base of 5? Well, 27 is the same thing as 3 cubed, right? So 27 to the x is 3 cubed to the x. Well, what's 3 cubed to the x equal? Well, our rule said that we multiply exponents, so it's 3 to the 3x. So this is the same thing as 3 to the 3x times 5 to the 2x. So we are going to try and put things together as best we can. I'm going to get my 3's and 5's all on one side. So over here, so I'm going to move the 3 and divide the 3 over. So I've got 3 to the 2x times 3 to the 4th over 3 to the 3x. That's being multiplied by 5 to the x times 5 to the negative 2 over 5 to the 2x. That all equals 1, so we have that divided over there. So how do I create 15 to the x? How do I do that? Well, what I need in order to make 15 to the x is I need a 3 to the x times a 5 to the x. So that's what I need. So in order to make that, I am going to break some of this up. So I've got 3 to the, excuse me, sorry. So I do notice that I have 2x on top, 3x on bottom. Excuse me. And I have the same situation over here. I could subtract away the exponents going down as much as I could go forward to create 5 to the x. So what I'm going to do is I'm going to simplify this to 3 to the 4th over, because I'm taking 2x away on the bottom, I end up with 3 to the x, times, same thing on this side, I'm going to take this x and subtract it down. So I'm left with, here with 5 to the negative 2 over 5 to the x, and that equals 1. This is the same thing if I multiply these back over. This is the same thing as 3 to the 4th times 5 to the negative 2 equals 3 to the x times 5 to the x, which would mean that 15 to the x has to equal 3 to the 4th times 5 to the negative 2, which we could simplify this, right? So 3 to the 4th is 81. 5 to the negative 2 is 1 over 25. And so you could end up simplifying this to 81/25. So a little more complicated problem, but just by using what we can and the laws of indices, we can kind of manipulate things around to make it work for us. Okay, so now we move on. Like, how do we simplify or evaluate different values? Well, one thing that, especially when you're looking at roots, you want to try to find similar roots or any kind of root that we can find within it, because then we can remove that particular root. So like, if you think of 18 can be made up of multiple things, right? We could say 3 times 6. Well, the square root of 3 and the square root of 6 aren't things that we know. They're not made of squares. So we can't really do anything with it. But we could work with, say, 2 times 9. Okay, square root of 2 times 9. This is the same thing as the square root of 2 times the square root of 9. Because each of these has the same exponent, if we were to multiply them together, they would just join together and have the same exponent. Well, the reason why this is beneficial is because we know that the square root of 9 is 3. So this is the same thing as the square root of 2 times 3, which we would rewrite this like this. So this can be simplified into 3 times the square root of 2, and that would be something you'd be expected to do. Now, 147 to the 1/2, that's the same thing as the square root of 147. So, can we think of any squares inside of 147? Well, 9, well, we start off with 4. Well, no, this is not going to work because it's odd. 9 could possibly work. If we see 9 goes in, you could find that that's not going to happen. Then next thing you go to 16, which that's even, so that's not going to work. 25, no. 36, no, it's even. 49, no, it actually does work. This is the same thing as the square root of 3 times the square root, square root of 3 times 49, which we could separate that. And to combine a couple steps at worst, what's the square root of 49? Well, that's 7 times the square root of 3. So that's how we could simplify this surd as quickly as possible. So trying to make things simpler and using smaller numbers is always good key and easy for us to make operations with. Okay, so now let's say we have this long list, and we need to figure out some number that's in common to all of these. Okay, well, if we look at 27, you've got 9, you get 3 as multiples, 27 is itself. So 75 doesn't have 9, but it does have 3. 48 has 3, but not 9. So we're going to want to look to see what happens when we divide all these things by 3. So here, 48 is the same as 3 times 16. 75 is the same as 3 times 25. And 27 is the same as 3 times 9. So we've got different counts of all of these things. The square root of 16 is 4. So I've got 4 of the square roots of 3's. Then the square root of 25 is 5. I have 5 square roots of 3. And then finally, I have square root of 9. That would be 3 times the square root of 3. So these numbers come from here. Well, if you have 4 plus 5 minus 3 of something, that is 4 plus 5 is 9, minus 3 is 6. So you have 6 times the square root of 3. So that would be a full way to simplify this whole thing. We can't simplify the square root of 3 anymore because it's just a decimal, and we don't want to do that. Okay, well, what happens if I have to FOIL something with a square root? How do I deal with that? Well, the only time you're going to simplify anything with a square root is if it equals something else. If you can't simplify it, then don't. So we do FOIL. So FOIL starts out as 5 times 7, which makes us 35. We then do the outside, which is 5 times negative square root of 2. I don't know what that is, so it's just negative 5 times the square root of 2. The inside is 3 square root of 2 times 7. Well, 3 times 7 is 21, so I have 21, but square roots of 2, so plus 21 square root of 2. I can't simplify that anymore. And then lastly, I have 3 times the square root of 2 times negative square root of 2. Well, the negative and the 3 make a negative 3. The square root of 2 and the square root of 2 make a 2. So let's see if we can simplify this. So I've got 35. I can't combine them with any of these square roots of 2 stuff because I'm not talking about square roots of 2 with 35. And I have this minus 6. So these two combine to make 29. I then have minus 5 square root of 2 plus 21 square root of 2. So this is plus 16 times the square root of 2. So that would be a fully simplified way of writing this out. Okay, so now we look at some different simplifying problems. Well, with this type of problem, 8 over the square root of 2, we need to get rid of the square root of 2. So we would multiply it by itself, and we have to multiply the top by it as well in order for this whole thing to be 1. So we get 8 times the square root of 2 divided by 2. Well, 8 over 2 is 4 times the square root of 2. Okay, and we look at the bottom. The only thing that's aggravating us here is the square root of 6. So that's what we're going to multiply by. So we're going to multiply top and bottom by the square root of 6. Well, we already have square roots in the numerator and denominator. So 2 times the square root of 7 times the square root of 6, so we get 2 times the square root of 6 times 7, which makes 42. Which, there are factors of 42. 1, 3 is a factor. It's 3 times 14. We have 4 isn't, 5 isn't, 6 times 7, obviously. None of those are squares, so that we can't reduce that. And then our denominator is going to be 5 times square root of 6 squared, or 36, which we know that to be 6. So the denominator becomes 30. We can then reduce that. 2 over 30 makes 1 over 15. So we have the square root of 42 over 15. Okay, last example we're going to do is, in order to rationalize the denominator here, we have to use a complex conjugate. It's all based off the a plus b times a minus b thing. That's because we get rid of our middle terms. And so if we were to do that, 5 plus the square root of 3 is like a plus b. We must pair that with a minus b, which is going to be 5 minus the square root of 3. And we have to multiply the top and bottom by that. So when we do this, you have to FOIL the top. You have to FOIL the top and technically FOIL the bottom, but the bottom is going to simplify very easily for us. So we do the first, which is 2 times 5 to make 10. And then do the outside, which is 2 times negative square root of 3, which makes negative 2 square root of 3. Then do the inside, which is the square root of 3 times 5, so we get positive 5 times the square root of 3. And then get the final part, which is positive square root of 3 times negative square root of 3, which is just going to make negative 3. We then divide. This special case in the denominator, the only time you can do this, we have 5 times 5, which makes 25. And then we have positive square root of 3 times negative square root of 3. That's going to make negative 3. And the middle terms cancel. And so we just need to simplify. So we're going to have 10 minus 3 at the top. So 7 plus 3 times the square root of 3 all over 22. And this is your final answer. So you have to rationalize. In order to get rid of the square roots in the denominator, the only way to do that when you have these multiple terms is to multiply by its complex conjugate.